Hi, for this road safety of the project, our group selected the area at Dataran Cendrika, Wilayah Shah Alam as the study location. This area was chosen because it experiences frequent movement of vehicles, buses and pedestrians, especially students using the bus stop and surrounding facilities. The first road safety element in this study is speeding. Based on our initial observation at the selected location, vehicles were seen travelling at a relative high speed, even though this area is frequently used by students and pedestrians. This raises a safety concern because higher vehicle speeds may reduce the driver's ability to ride safely, especially near the pedestrian crossing and bus stop area. To further investigate this issue, our group conduct a spot speed study to determine the actual speed of vehicle passing through the study area and to check whether drivers were complying with the UITM campus speed limit. Based on the data collected, we found that the majority of vehicles were travelling at approximately 35 km/h, which exceeds the campus speed limit of 30 km/h. In areas with high pedestrian activity, speed control is particularly important because higher vehicle speed reduces driver reaction time and increase stopping distance, which may increase the risk to pedestrian crossing the road. This finding shows that speeding is one of the safety issues at this selected location. As the mitigation measure, we propose that a 30 km/h speed limit sign be installed clearly before the pedestrian crossing area. This is important to alert drivers early and to give them enough time to slow down, thus improving safety for students and other road users.
My name is Muhammad Syarul Nizam bin Muhammad Abdul Suki. So next, I just want to share a little bit about the road design, which is horizontal and vertical alignment. So let's take a look.
So right here, this is an example of horizontal alignment. See this curve? This is part of road design to follow the nature landscape or avoid obstacles.
In place like this, we also need to consider super elevation, which is mean the road slightly tilt during the curve. It helps the vehicle to stay on the track and not skid off. So now we are at a Malati area and is an example for vertical element. You can see the slope going up and going down. It's called the gradient. If the slope is too steep, it's difficult to vehicle to climb up and dangerous to going down. That's why road designer make assure the slope follow the safety standard.
We look at elementary cross-section. A road cross-sectional element including lane width, shoulder, median and crossfall are fundamental in determining lateral vehicle clearance and providing a forgiving roadside environment. On this specific vertical and horizontal curve section at Dataran Cendrika, the cross-sectional design directly dictates how safely vehicle can share the space. Observed during our field audit, this operates as a multiple lane undivided pavement directly adjacent to a high-activity pedestrian hub. When heavy vehicle or standard car navigate this tight curve simulators, this is minimal lateral clearance. The absence of a physical median or a wider center painted buffer means that vehicles often hug or cross over lane marking. This increases the probability of sideswipe, conflict, or head-on friction, particularly when drivers are forced to react suddenly to pedestrian crossing at the Dataran Cendrika. Our field analysis indicate that while the lanes accommodate standard passenger car, the cross-section is highly concentrated during peak campus traffic hours when buses and passenger vehicles travel side by side. According to JKR, Arahan Teknik Jalan 8/86 geometric design of road, curve segment with high bus volume require lane widening or a curve widening factor to account for vehicle off tracking. The current cross-section lacks this widening, causing large vehicles to encroach onto adjacent lane. To optimize this cross-section for better operational performance and support SDG 9 and 11 for stable infrastructure, we propose the following mitigation. First, redesign the lane configuration to include a clearly marked painted central flash median buffer to separate opposing traffic flow and give vehicle more lateral breathing room. Second, introduce highly visible H-line rumble strip or tactical marking near the curb line to prevent vehicle from drifting into the pedestrian sidewalk zone.
Hi, my name is Aina Hana Aziati binti Abdul Aziz. Today I will present element 4 geometric layout. To see how this junction layout handles traffic, we did a manual volume study using a telecounter during the evening peak hour. As you can see from the data, Direction 6 picked up the highest volume with 385 vehicles, followed by Direction 2 with 375 and Direction 5 with 348 vehicles. So overall, the evening peak was very busy, which makes total sense since people are probably leaving campus or heading home. Geometrically, all these heavy turning movements heavily conflict with the mainstream because the physical layout is quiet type. It forces these high volumes to queue up, making the yellow box absolutely critical to prevent gridlock.
The next element in this study is traffic signal, particularly in relation to pedestrian crossing control. Based on our observation, a high number of students were seen crossing the road throughout the day, especially to access the bus stop and surrounding facility. Although a pedestrian crossing is already provided, the crossing movement is still considered unsafe because some students cross the road while vehicles are still approaching or moving throughout the area. This situation creates a potential conflict between pedestrian and vehicle and increase the risk of accident, particularly during peak period when pedestrian activity become higher. In some cases, students may cross without waiting for a fully safe gate, while drivers may continue traveling through the crossing area without slowing down sufficiently. As the result, the crossing area does not fully provide a safe and controlled environment for pedestrians. Therefore, as a mitigation measure, we propose the installation of pedestrian traffic signal at the crossing area. This will help control the movement of both pedestrian and vehicle more effectively by providing a dedicated crossing space for pedestrian and clear stop indication for driver.
Currently, there is no clear indicator to stop driver from making a U-turn. As a result, some vehicles make a sudden and unsafe U-turn at this junction. This kind of movement is risky because it can interrupt flow of the traffic, cause the confusion and even lead to accident, especially when there are pedestrian crossing nearby or when the road is busy. To solve this, we recommend the installation of a no U-turn sign before the junction. This sign will inform the driver that U-turn are not allowed in this area. This helps to guide driver behavior and vehicle follow safer, more organized traffic follow pattern. The expectation outcome from this improvement include better traffic control, fewer sudden or illegal turn, and improved safety for both driver and pedestrian. It also supports a more predictable and smooth flow of the vehicle, especially during the peak hour.
Next, let's look at element 7, vulnerable road user infrastructure. In a campus environment like UIT and Shah Alam, students working waiting for transit or cycling represent the majority of road users. Protecting this vulnerable individual requires highly structured, continuous infrastructure that separates foot traffic from heavy vehicle flow. Our audit at the Dataran Cendekia Strand highlighted a major conflict zone. This location actually as a primary transit hub, seeing high volume movement of large multiple exit campus shuttle and public smart Selangor buses. While a designated pedestrian zebra crossing and a yellow box junction are present to manage traffic, the proximity of the heavy bus drop-off zone directly adjacent to the uncontrolled crossing create a high-risk blind spot. Pedestrians stepping out from behind a stopper bus are highly vulnerable to oncoming vehicles traveling in the adjacent lane. To foster a safer environment and support SDG 11 for sustainability, cities and communities, we propose the following targeted engineering intervention. First, elevate the current zebra crossing to create raised pedestrian crossing or speed table. This physically forces upcoming vehicles to drop their speed to a safe 20 or 30 km per hour before approaching the bus stop zone. Second, install pedestrian refuge islands or clear active warning signage upstream to alert driver well in advance of this high-yield student zone.
Okay, next, moving on to element 8, which is roadside safety features. First, we observe some students crossing haphazardly. However, the infrastructure provides a proper zebra crossing and warning signboard to manage pedestrians' conflicts. Drivers and pedestrians must cooperate to stay safe here. Second, pedestrians are using this uncovered train as a shortcut to go to faculty. This presents a severe tripping hazard due to the drop-off level. The lack of crating also allows road debris and rubbish to accumulate, which can cause localized flooding. On a positive note, the covered walkway provides excellent physical segregation along the curve. Finally, the speed hump and yellow transverse markings serve as effective speed calming measures.
The next element in this study is street lighting. Based on our nighttime observation, the lighting condition at the study area was found to be generally adequate and satisfactory. The existing street lights were able to provide sufficient illumination along the road section, allowing drivers to see the road alignment, surrounding vehicle and pedestrian movement more clearly during nighttime condition. However, regularly maintenance and monitoring of the lighting system are still recommended to ensure that all street lights remain functional and continue to provide safe visibility for all road users.
So next we move on to the landscaping element. Now I am sure many of us feel how hot it can get in the afternoon, especially when waiting outside. This heat is not just uncomfortable, but it can also affect our safety and overall well-being. First, we propose planting large shade tree beside the bus stop. The goal is to create a cooler and more pleasure waiting area for students, especially during the hot afternoon and evening hour. This tree will provide natural shade, reducing direct sunlight and making the scape significantly more comfortable. The benefit go beyond comfort. Editing tree will also enhance safety by reducing the risk of heat-related issue. Plus, they will improve the aesthetic value of the surrounding, making our campus look more greener and more inviting. Environmentally, this initiative supports sustainability by helping to reduce heat build-up and improve air quality. It is a small step with a meaningful impact. We recommend fast-growing broad canopy tree that require minimal maintenance. This ensures that the solution is both effective and practically over time. Ultimately, this simple landscaping improve will enhance the daily experience of students who rely on the public transport and contribute to a healthier, more comfortable campus for everyone.
Moving on to road surface. A safe road surface must provide adequate skid resistance, a smooth riding quality, and structural integrity. However, during our audit along this segment, we observed significant pavement distresses that pose severe safety risks to campus road users, particularly motorcyclists and cyclists. As seen here, we identify clear structural and functional failure. First, there are active potholes and severe riffling where the aggregate has separated from the bitumen binder. Second, look at the drainage utility grading. The surrounding asphalt has completely deteriorated, creating a sudden drop and uneven profile. This acts as a severe hazard that can easily destabilize two-wheeling vehicle or cause driver to swerve abruptly, increase the risk of sideswipe crashes. Based on our field analysis and comparison with JKR standard, the pothole exceeds a depth of 50 mm classify them as high severity distresses that require immediate structural intervention. Furthermore, the average level difference around the iron grading creates an unacceptable vertical deformation, failing the structural safety requirement for campus link roads. mitigate this hazard and support SDG 9 and SDG 11 for resilient campus infrastructure, we propose two critical solutions. First, localized tap patching and a localized fill and overlay to restore a uniform pavement texture. Second, releveling and reinforcing the concrete surround of the drainage grating so it is sit completely flush with the newly laid out surface.